My guest is an extraordinary Miamian, Dr. Jacques Fresco. I could go through all the things that Dr. Fresco has done. He's a social engineer, industrial engineer, designer, inventor, consultant, was a consultant for Rotorcraft Helicopter, director of Scientific Research Laboratories, Los Angeles, designed and copyrighted various items ranging from drafting instruments to X-ray units. Has had works published in the Architectural Record, Popular Mechanics, Saturday Review, and has been a technical and psychological consultant to the motion picture industry, member of the Air Force Design Development Unit at Wright Field, developed the electrostatic anti-icing systems, designed prefabricated aluminum houses. What does it say in your driver's license? What is the occupation?
Industrial designer.
Jacques, you...
Social engineer.
Does it bug you that people, when they talk about Jacques Fresco in Miami, say that he's someone who's too far ahead of his time? His thinking is, we're not ready for advanced kind of thinking, of that type. Does it bug you?
I imagine every creative person in every field encounters that sort of problem. No, it doesn't. I can't afford it. There's too many things that are important.
The water of the oceans of the world is almost always in motion. Hardly ever interrupted, waves break at the coastlines, sometimes strong, sometimes weaker. There is an enormous energy potential that is available round the clock and free of charge. A potential that, if fully exploited, could satisfy 40% of the worldwide demand for power. This equals the output of 700 to 800 nuclear power stations. The operating principle of this wave power station is as simple as it is ingenious. An enclosed chamber has an opening beneath sea level, which allows water to flow from the sea to the chamber and back. The water level in the chamber rises and falls with the rhythm of the waves, and air is forced forwards and backwards through the turbine, connected to an upper opening in the chamber. As it is compressed and decompressed, the airflow has sufficient power to drive the Wells turbine. It is a feature of the Wells turbine, named after its inventor, that it is driven in the same direction by both forward and reverse airflow through the turbine. Even relatively low wave motions can generate enough airflow to keep the turbine moving and to generate energy. The world's first power station of this kind was put in service as early as November 2000 on the Scottish island of Islay, and has been feeding power to the grid ever since.
Sea creatures are inspiring the latest devices that harness wave power. This one, called the oyster, sits on the ocean floor and opens and closes as waves pass over it. Cables attach it to generators on the shore. Since November 2009, it's been powering 9,000 homes in the Orkney Islands. Another device looks like a snake. The anaconda is made from a rubber tube filled with water that floats just below the surface. When a swell hits the front of it, the tube is squeezed. A bulge ripples down its length and powers a turbine in its tail. Prototypes are currently being tested, but the full-scale version will be 200 meters long.
inside of the collector area looks like. 4.4 hectares of plastic material called tetla, polyvinyl fluoride, which is held in position here by these spreaders like that. You can see them underneath here, pulled down by this heavy weight. And that's to keep everything tight so that it can handle the high winds that are generated, not only by the air flowing through to the chimney, but also in this area generally, winds can get up to around 150 kilometers an hour. During the day, the heat builds up here to around 50 degrees centigrade, and the air starts flowing in continually towards the chimney. But the interesting thing is that it also works at night as well as day, and in cloudy and rainy spells as well, because not only the air, but the ground beneath it is heated up during the day to such a degree that in the nighttime it re-radiates that heat back again, keeping the air warm and flowing inwards towards the chimney all the time. Instead of a desert developing underneath this collecting area because of the high temperatures here, they got instead quite luxuriant plant growth underneath because of the greenhouse effect, which produced large quantities of condensation during the night. Well, this is the funnel, as it's known, and it's not much more really than two curved capes made of a polymer-coated fabric, which gives a smooth transition for the air that's coming in from the collecting area outside and going up into the chimney above me here, where you can just see the blades of the turbine turning slowly around. Well, it's switched off at the moment because they're making some adjustments. This solar chimney in Spain has demonstrated that it will be possible in the future to compete on a dollar-for-dollar basis with virtually any other form of power generation, with that one unbeatable advantage that it's got an inexhaustible source of free, original energy in the sun.
The floral panels introduced as windows that generate electricity are prototypes of the dye-sensitized solar cell being developed by Sony. Light energy absorbed by the color parts is converted to electricity to drive a propeller. A feature of these panels is that they can be fabricated easily by coating electrodes with dye and affixing them next to each other. The simple manufacturing processes of coating and printing give these panels a lot of freedom in design. They also have high generating performance indoors and under low light, and their performance doesn't deteriorate even if the light's angle of incidence changes. These features are expected to enable the new solar cells to be used in a variety of everyday applications for which conventional solar cells have not been suitable. As a mobile application, Sony also displayed a solar charger with dye-sensitized solar cells. The pattern on the surface of the panel generates electricity which is stored in a lithium-ion charger. At Echo Products 2009, Sony used an indoor light source to actually power a Walkman as a demonstration.
The natural heat of the Earth creates geothermal resources. This heat comes from molten rock called magma, located at the Earth's core, deep below the geothermal resource. Over thousands of years, rainwater seeps through cracks in the Earth's surface and collects in underground reservoirs. The magma heats the water until it becomes a superheated fluid. To reach the superheated fluid, wells are drilled 5,000 to 10,000 feet below the surface of the Earth. These wells, called production wells, bring the superheated fluid to the Earth's surface, where it can be used to generate electricity for homes and businesses. Under its own pressure, superheated fluid from the geothermal resource flows naturally to the surface through production wells. As the liquid flows toward the surface, the pressure decreases, causing a small portion of the fluid still within the well to separate or flash into steam. At the surface, the superheated fluid and steam mixture flows through surface pipelines and into a wellhead separator. Inside the separator, the pressure of the superheated fluid is reduced. This causes a large amount of the superheated fluid to rapidly vaporize and flash into high-pressure steam. The geothermal fluid that is not flashed into steam in the wellhead separator flows to a second vessel called a standard pressure crystallizer, where an additional amount of standard pressure steam is produced. The flash process continues in the low-pressure crystallizer. The remaining fluid is again flashed, this time at a lower pressure to produce low-pressure steam. All of the low-pressure, standard pressure, and high-pressure steam is delivered to a turbine. The fluid that is not flashed into steam flows into the reactor clarifier system and is then returned to the geothermal reservoir through injection wells.
Some of this energy has already been harnessed for mankind. The geothermal plant at Werrikai supplies 18% of the electricity needed by New Zealand's North Island.
Maglev Wind Turbine Technologies Incorporated has now made the quantum leaps in wind power harnessing innovation that will replace wind farms currently requiring tens of thousands of acres. Maglev Wind Turbine Technologies inventor Ed Measure has created this industry-evolving sail-fin generator, which replaces 1,000 inefficient propeller towers, producing up to 2 gigawatts of renewable power on less than 100 acres with minimal environmental impact. This is because Maglev Wind Turbine requires no input power source. It rides on a frictionless earth magnet base and frictionless gears, requiring minimal maintenance. With on-site power storage and conversion, Maglev Wind Turbine is grid-ready and self-sufficient.
The vertical farm concept started in a classroom. Traditional farming, everybody's familiar with it. You know, you plow the land, you plant the seeds, you water and you fertilize and you grow and then you harvest and then you ship. That's normal farming. Now vertical farming does the opposite, except for one thing. Vertical farms still make your food, but they employ closed-loop agricultural technologies. That means all the water is recycled, all the nutrients are recycled, and the only thing that actually leaves the building is the produce.
This is a type of hydroponic growing system, and you have multiple layers of plants to maximise the space for cultivation. The top trays are going to get the maximum light. The lower trays, particularly the bottom ones, are very shaded. But by it moving, that opens up the trays to different angles of sunlight. This system's great to have in the zoo because we're growing the crops here. They go straight out the same day to the animals. They're not refrigerated at all, so they have all those sugars really intense and really sweet. The plants are growing in a bath of water. This water is changed each time the crop's watered, which allows fresh nutrients and oxygenated water to go in. Hydroponics is a great system for growing crops because it optimises the food and water that the plant gets, which maximises the speed that the crop can grow and maximises the nutrients that are going to be contained within that crop.
There's some real opportunities to connect people to the systems that sustain us in a new urban environment. So we can actually see the water tanks. We might even be walking between the water tanks at the street level. We would be adjacent to the photovoltaic panels that were collecting the solar power. We'd be walking past the restaurant that was serving the food from the roofs above. So there's a lot of opportunities to connect people with these food systems and these ecological systems that are part of the new city topology.
We imagined a new place in town. A place where healthy food is produced, where research to guarantee food security is carried out, where you may learn and taste, a place designed to host quality for your well-being without pollution or waste, a place just around the corner.
The biggest social benefit is that everybody gets fed healthy, clean food, and we can use it to remediate water so you can have safe water and safe food wherever you live. I've had no negative reaction to this idea whatsoever. I have a very positive reaction to it, and I think the idea is about to develop into reality.
The RetRap project is a project to make a three-dimensional printer, that is to say a device that you plug into the USB port of your computer and it prints out solid three-dimensional objects. It's to make that device and to make it both open source and self-replicating. So it's a 3D printer that can print out a significant fraction of its own parts, though not all of them. And it's open source, so if you've got a RetRap printer, you just download the design off the web for free and you can print another copy of it and give that to your friend. The parts that it doesn't print for itself are all designed so that they're universally available everywhere in the world for very low cost. The key thing about metals is not so much their strength. In fact, the metal we're working with is not particularly strong, but the fact that they conduct electricity very well. If we can print both in plastic, which of course is an electrical insulator, and an electrical conductor, then we can build three-dimensional electrical circuitry which liberates us from the necessity of making printed circuit boards. We can embed the electronics of a device within its mechanical parts. So for example, we could have an artificial limb which contained the electronics to drive the actuators in that limb embedded within what are effectively the artificial bones. Now, when I say electronics embedded, I should be clear that the RetRap machine makes the connections. It's not yet making the chips, which require much finer resolution than the machine currently works at. To make objects that are currently manufactured in conventional factories will extend that whole idea into virtually every solid thing that we have in our homes.
The introduction of highly sophisticated computer modeling technologies has meant that designing the shape and form of a building is now only limited by an architect's imagination. Leading architectural practices such as Foster & Partners are designing buildings to a level of geometrical complexity unheard of 10 years ago. However, while these forms can often be achieved through off-site factory-based manufacturing techniques, there are significant limits to the levels of intricacy attainable. For example, pouring concrete into a framework can go some way to fulfilling these ambitions, but the reality is that the achievable complexity is still limited. The manufacturing processes required to turn these complex building designs into reality have remained elusive until now. This may be about to change if current research by scientists at Loughborough University comes to fruition. The research group has been inspired by 3D printing, an additive manufacturing process. Here, information created from computer-generated models is exported to a machine which then builds up a model or a component, layer by layer. The virtual model is, in effect, materialized. At Loughborough, instead of using powder and glue, they are experimenting with concrete to create large-scale building components.
The research here at Loughborough University gives us tremendous opportunities. We are able to have a little peek into the future to see what construction technology will be in the next 5 or 10 years.
Concrete printing works on the basis of a highly controlled extrusion of cement-based mortar, which is precisely positioned according to computer data. The process has the potential to create architecture that is more unique in form, but crucially, components do not have to be made from solid material, and so can use resources more efficiently than traditional techniques.
We have shown how additive manufacturing can be developed to create large structures such as panels and walls, with precisely controlled voids within them.
For example, the section which you can see being manufactured here could incorporate all the service requirements of a building, such as pipes and cables, in one unit.
This process is capable of producing building components with a degree of customization that's not yet been seen. It could create an era of architecture that's adapted to the environment and fully integrated with engineering function.
Imagine whole sections of a building being printed and then assembled on site with their service provision already installed.
The Ultra PRT, short for Personal Rapid Transit, is basically a taxi crossed with a metro with none of the disadvantages.
I just thought transport was not done well. And I believe that if we thought about transport in a proper way, we would come up with a better way of doing it. And this is the result of that process.
Adam Ruddle, the PRT's lead engineer, explains how it works.
The passenger is going to come to the station, buy his ticket, and then when he gets to the vehicle, he will select the journey that he wants. He'll get into the vehicle. The vehicle will now be told by a central computer where it's going to. The vehicle then completely autonomously drives you from your start to your end station without stopping anywhere along the way in between. The vehicles that are going to a station will drive away from the main guideway into the station area. That means everybody who isn't going to that station carries on along the main guideway at the full speed of the vehicle. That way, you travel very quickly from your start to the end of your journey and are not delayed by anybody else's travel whatsoever.
It's quick, it's safe, it's easy to use, and it's pretty cool to look at. The Ultra PRT may just be the answer to India's heavily congested and potholed streets, and given how little it costs to build and how quickly it can be built, it may soon be headed to a neighborhood near you.
Over the weekend, Google made an announcement. They actually have bought the universe. No, but they have been secretly developing vehicles that can drive themselves on public roads, and they already logged 140,000 miles with their fleet of prototypes. In a press release this past Saturday, Google reaffirmed their position in the world. Google was founded to, quote, help solve really big problems using technology, unquote. One of those big problems is car safety and efficiency. Thus the reason to create new technology to improve autonomous vehicles. Recruiting top automotive engineers who have worked in the DARPA Challenges, a series of autonomous vehicle races organized by the U.S. government, Google has had their fleet successfully autonomously navigate everything from the Pacific Coast Highway to Lombard Street. Using video cameras, radar sensors, laser rangefinders, and detailed maps collected both from other vehicles on the road and Google's data centers, the cars can theoretically navigate any road. The World Health Organization claims that more than 1.2 million people are killed every year due to road traffic accidents. Google believes this new technology will cut that number right in half. The objective is to make driving more efficient, reducing braking and accelerating, which would ultimately save fuel.
Here at Virginia Tech University, where engineers from Torque Technologies and Virginia Tech have built a car that can drive itself.
Despite what it may look like, Odin's not driven by remote control.
There is no one in the driver's seat. Andrew's just cruising along, watching the computer.
To prove that, I took a ride myself. The car drove about 100 yards, made a 3-point turn, and drove back to its starting point.
So we've reached the end of this road segment and turning around. This is not a pre-programmed move. Depending on the geometry of the road or anything else here, it'll adjust to figure out the best way to go back and forth.
So how does it work? A complicated system of navigational devices, cameras, and scanners.
So there's a total of 7 mounted on the vehicle. There's 3 at bumper level. So what this is doing is it's sending out laser beams and scanning all around the car about 12.5 times a second. So these are looking for other cars, they're looking for people, they're looking for trees, any sort of other obstacles that you might find. The 2 on the front are looking down at the road. So they're looking for where the road is, where curbs are, where very small obstacles are, where potholes are, things like that. So how many decisions is this car making per minute or per second while it's driving? It's recalculating its path about 10 times a second.
The first thing you have to do is press this main button here, which switches on the system, and you have the ACC and LCAS buttons being enabled. We then set the adaptive cruise control, and you can increase the speed of multiples of 2. So here we are, I've set it at 68 miles per hour. You can see and identify a vehicle in front, and it is keeping 2 chevrons behind that lorry. And then with this button here, you can change the distance between you and the car ahead to effectively 3 chevrons, 2 chevrons, or 1 chevron. Then if I press this button here, the LCAS button, the camera now starts to see the lines in front, and I can feel the response. You'll see the steering wheel actually turning itself from the camera, monitoring the road ahead, watching the bends, and then feeding that input into the steering wheel. Now if I were to totally let go, which is obviously illegal, so I have to be very careful here, what the system does is it recognises that there's no steering input from me whatsoever, and after 10 to 15 seconds it would beep to say, look, I'm turning myself off, ultimately you're the driver, you're responsible for this car, this is just an assistance package. And there we go, it's just beeped, and I have to hold on to the steering wheel. It can feel that I'm now back in control of the vehicle for it to re-engage. Now this car is about to pull ahead of me. The system detects it, and I'm now starting to brake without me touching anything to keep a safe distance between this car and the car ahead. Now interestingly enough, I'm set to 68 miles an hour, but you'll see from the speedo that we're actually doing 55, because it says in order to stay in this lane and keep a safe distance from that car, I will have to reduce the speed accordingly. So what this means over a long journey It effectively means that you've got somebody else supporting you, which means that you're more alert, it's less tiring over a long drive, you can look around more, check your mirrors more, and be more alert to drivers on the road. Now also, if I want to overtake and change lanes, but I don't indicate what effectively will happen, and I'll show you here, if I go to converge lanes, the system beeps at me, tries to put me back into the lane. So if I do want to change lanes, I have to indicate, which makes me a better driver to those around me because they're seeing what I'm doing. And when I do indicate, what happens is the LCAS system, the lane keep, disables itself for a few seconds and then re-engages when you move into the next lane. If you come off the motorway and you go below 45 miles an hour, the lane keep switches off. You've got to remember that the lane keep needs both of the lines on the motorway to be able to operate. If it can't see either of those lanes, it'll turn off anyway.
Replacement of human labor with machines. At the core of the economic system itself is the mechanism of labor for income. Our entire economic system is based on human beings selling their labor as a commodity in the open market. If humans do not have the option to work for a living, then the monetary system as we know it is over. No one can buy goods if they don't earn money. Companies cannot afford to produce if the consumer has no purchasing power to buy anything. As John Maynard Keynes disdainfully pointed out, we are being afflicted by a new disease, of which some readers may not yet have heard the name, but of which they will hear a great deal in the years to come, namely technological unemployment. This means unemployment due to our discovery of means of economizing the use of labor outrunning the pace at which we find new uses for labor. While politicians, business leaders, and labor leaders bicker over issues they claim are responsible for the growing unemployment in the world, such as foreign company outsourcing or immigrant labor, the real cause is going unaddressed in the public debate, and that is technological unemployment. Since market capitalism is built upon the logic of reducing input costs to increase profits, the inclination to replace human labor whenever possible by machine automation is a natural progression of industry. After all, a machine doesn't need to take breaks, it doesn't require health insurance or benefits, and it isn't a part of a demanding labor union. A simple glance at U.S. historical labor statistics by sector shows the pattern of machine automation replacing human labor definitively. In the agricultural sector, almost all traditional workflow is now done by machine. For example, in 1949, machines did 6% of the cotton picking in the South. By 1972, 100% of the cotton picking was done by machines. In 1860, 60% of America worked in agriculture, while today it is less than 3%. When automation hit the U.S. manufacturing sector in the 1950s, 1.6 million blue-collar jobs were lost in 9 years. In 1950, 33% of all U.S. workers worked in manufacturing, while by 2002 there was only 10%. The U.S. steel industry from 1982 to 2002 increased production from 77 million tons to 120 million tons, while the steel workers employed went from 289,000 to only 74,000. In 2003, a study was done of the world's largest 20 economies, ranging from the period of 1995 to 2002, finding that 31 million manufacturing jobs were lost, while production actually rose by 30%. This pattern of increasing productivity and profit, coupled with decreasing employment, is a new and powerful phenomenon, with no changes in sight. So this might beg the question, where have all those jobs gone? The service sector. From 1950 to 2002, the percentage of Americans employed in the service industries went from 59% to 82%. For the last 50 years, the service sector has been absorbing the job losses from agriculture and manufacturing. Unfortunately, this pattern is slowing fast as computerized automation takes hold there as well. From 1983 to 1993, banks cut 37% of their human tellers, and by the year 2000, 90% of all bank customers used teller machines, or ATMs. Business phone operators have almost all been replaced by computerized voice answering systems. Post office Tellers are being replaced by self-service machines, while cashiers are being replaced by computerized kiosks. There isn't one area of the service industry that isn't being affected by computerized automation. Economist Stephen Roach has warned the service sector has lost its role as America's unbridled engine of job creation. Given this reality, where is the emerging new sector to employ all of the newly displaced workers? There isn't one. And while economists struggle to create models to deal with the issue of nearly unstoppable unemployment, most refuse to consider what is really needed in order to prevent a total breakdown of society. The solution lies not in attempting to fix the issues that have emerged, but rather it is time we transcend the system in its entirety. For the system of monetary exchange, along with capitalism itself, is now completely obsolete in the wake of technological creativity. If people do not have jobs, they cannot support the economy by purchasing anything. This reality is the final proof that our current system is now completely out of date, and if we want to deter riots in the streets and poverty on a scale never before seen, we are going to have to revise our traditionalized notions about how society functions at the fundamental level. We require a new social system that is updated to present-day knowledge and modern methods. Human labor is not only currently being replaced by machines because it is more cost-effective in the profit system, machine labor is actually much better than human labor, and output statistics have shown this continually. This, of course, should be of no surprise. For a machine does not get tired, and it is always more accurate and consistent than a human mechanically. Now, one of the more confusing and difficult components for many to consider has to do with the deliberate focus of using machines to replace human labor whenever possible. The question is always, who will maintain the machines? Machinery today is now being combined with computerization. Essentially, a computer is the brain of the machine, and it instructs the machine what to do. This combination of machine and computer intelligence could be termed cybernation. Cybernated machines today are probably the most powerful and influential invention humanity has ever created. The possibilities of these tools are on pace to changing the entire fabric of society, beginning first with the freeing of the human labor force. In the words of Albert Einstein, ultimate automation will make our modern industry as primitive and outdated as the Stone Age man looks to us today. This reality is not something we should fight. We should embrace it emphatically. Cybernation is the emancipation proclamation for humankind, freeing us from the drudgery of common labor, opening new horizons for human creativity and exploration. These cybernated machines far exceed the physical accuracy and endurance of the human body, while also being able to compute at incredible rates, also far exceeding the computational speed and capacity of the human brain. As far as application, the first step is to ensure that the cybernated machines we devise are of the highest quality components and programming. In order to do this, we would have to outgrow the monetary system, for it perpetuates inferior products for the sake of cyclical consumption. There is no reason why everything in your home, from your refrigerator to your stove to your television to your computer, could not last your lifetime without physical repair. How can that be said with confidence? Because the best materials available on this planet, such as titanium, have sustainable properties that far exceed the life of a person by thousands of years. The cybernated machines would not be bought and sold, they would be built and designed to last. Not only will they have extreme durability and long lifespans, these advanced machines will eventually be able to repair themselves. In cars today, there are often warning lights on the dashboard that will alert you to a problem with a particular part of the car. This idea can be expanded in all machinery to the degree where not only is the machine's onboard computer aware of a problem, supplemental machines can thereby be directed to replace the broken part in real time. As fanciful as it may seem, self-repairing machines, structures, and even circuits are growing realities. The problem is that the production of such efficiency is not rewarded in the monetary system, so most people in society have no idea of what is actually possible. Furthermore, the role humans will play within this automated system will be that of supervisors, and nothing more. Once a fully integrated, autonomous, cybernated industrial system is set up, it is simply a matter of updating the system and making sure the system is in order. As time moves forward, we can only expect that the rate of our technological capabilities will continue to increase, perfecting this system. Now, while most people today recognize society's use of machine automation in manufacturing and the like, many have a very difficult time seeing how automation can be applied to complex jobs, such as doctors, architects, and the like. In order to consider this, we first have to ask ourselves what the true nature of our occupational roles really are. What exactly is a doctor, a carpenter, a plumber, or an architect? What are they actually doing? They recognize and react to observed patterns. When a doctor examines you, all he or she is doing is mentally referencing what has been learned. If you go to a dermatologist because you think you might have cancer on your arm, the doctor is going to examine the skin and mentally reference the patterns he or she has been taught. Then they might take a sample of the skin to be tested by machine analysis. It is a technical process. There is no reason why, say, an optical scanner connected to a computer database could not be invented which could scan your arm and immediately understand what problem exists. Even surgery, as sensitive as it may seem, is a purely technical process. It is simply a matter of time before extremely advanced machines replace surgeons. The same goes for every other utilitarian occupation in existence. And this brings us to a very critical realization, one that will have a profound effect on our progress on this planet. The conscious delegation of decision-making to computers is the next phase of social evolution. Human nature is defined as the shared psychological attributes of humankind that are assumed to be shared by all human beings. Therefore, the implication of the term is that certain psychological, hence mental behaviors are in some way hardwired into a person. We are thus supposedly born with some preset psychological inclinations. It is easy to see how this kind of assumption has manifested. For if you look at the historical record for the human species thus far, we see an endless series of wars, genocides, conquests, and power abuses. Given that this is the pattern we recognize, it is easy to assume that it must be some set human nature to behave in ways that are historically reoccurring. Furthermore, so-called criminal behavior has been a focus of psychologists for some time. Is it the responsibility of an individual's genetic makeup that makes them a so-called criminal? Or is it the environment in which they are raised that determines this? This is the age-old question of nature versus nurture. First, what exactly is criminal behavior? How do we qualify behavioral distinctions that have been invented by man and change with time? The entire concept of criminality is temporal and relative to a culture's values and concepts of morality. Only 600 years ago, certain indigenous cultures around Mexico engaged in mass human sacrifice, often killing thousands at a time. Was this criminal activity? To us, perhaps, but to them it was accepted social custom. What about the generations and generations of accepted slavery? Is a criminal someone who steals food in order to feed his or her starving family? The bottom line is that there is no concrete scientific evidence that really supports the notion that any of our behaviors are strictly the result of our genetics. The notion of human nature is largely mythological. It stems from primitive religious dualities that the human is good or evil inherently. The pursuit of people who seek the gene or the like, which is supposedly the cause of a particular behavior, is essentially a form of superstition. It is like a person being possessed by demons, which control their actions. The fact is, while neurochemicals and physiological traits set propensities for a person's reactions and social gravitation, it is the environment that really creates our values and behavior. We must realize that we are on our own on this planet, and it is up to us to change the world for the better. It is time we stop pontificating and providing lip service to those spiritual values which religious and secular philosophers have been discussing for millennia, and finally put them into practice. Science is the tool for this functional spirituality, and if we work to apply its methods for the betterment of civilization itself, we can reach the spiritual goals we have sought since antiquity.